Hello and welcome in. Mark here, aka the Markster. This is video number 37 in the FreeCAD series. Today we're going to try to make a mobius strip. What you're seeing here is the Wikipedia page on mobius strips. And here's a 3D interactive model that this user here, Kit Wallace, made on Thingiverse. So this is what I'm going to try to make in FreeCAD. So the interesting thing about this is it's got two sides, but they're both the same side. So imagine imagine an ant walking along this face. As it comes around this side, now he's on the back side. And if he went along the back side again, he'd come along under it and end up back on the front side. So it's one continuous face. This design can be useful in situations with like a conveyor belt. It'll last twice as long because you're spreading the wear out on both sides in some cases. So we're going to try to make that or one like it in FreeCAD. So I'm going to do this in the part Workbench, not in part design, because I want to make an array of sketches representing that profile and sweep that profile around. Actually, loft from sketch to sketch, each copy being rotated slightly. So I'm going to make a polygon, and this is going to be an 18-sided polygon, radius of 100 millimeters. And the purpose of this is I'm going to have my sections right here in the middle, and I'll use these edges as reference points because these will be the axis of rotation for each sketch. So I'm going to go to Sketcher now and make a new sketch, and I'll put this sketch on the YZ plane. So when I tilt a little bit, you can see that polygon. So I'll make a little rectangle here. The center of the rectangle using the point-to-point symmetry. I accidentally selected that horizontal axis. I'm going to have this the width of the belt just 40 millimeters, and this will be the thickness of the belt in this direction, and that'll be 5 millimeters. And now I'm going to move that sketch in the Y direction to 100 millimeters. It's not perfectly lined up. That's a circumradius. The circumradius of the polygon. So you'd have a circle coming around here, and that would put it right in the middle. So this is 5 millimeters. Changed my mind. Instead of moving the sketch, let me reset this. Instead of centering it, I'll create a link to external geometry. That's going to be problematic too, I think. Let's see, we'll try it. So add a point here in the middle. I need this on the YZ plane. That's what it's on. It's got me confused here. I'll rotate the attachment. Let's see. Oh, I think what I did was when I reset this, it put it on a different axis. Okay, that's how I want it oriented. Now if we make a polar array in the draft workbench of this sketch, let's see what that's going to look like. Let's see. I want 18 of these little guys. So we'll rotate them 10 degrees each, using these edges of the polygon as a rotation axis reference. And then we'll loft between them. So it'll make a full 180 degree twist by the time it gets all the way around. So you can make your own mobius strip if you just have a strip of belt or even a strip of paper. Cut it and give it one half twist and tape it back together. So we're going to do something similar to that here. So now what we need to do is go back to part, and we need to explode this array so we can get at these individual sketches. And we use explode compound for that. So now we have the individuals that we can rotate. And we'll be starting there at the top, and that'll be at 0. I'll leave it at 0. Then this will be at 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees, 100, 110, 120, 130, 140, 150, 160, 170, and we'll link back to this one. I'm going to make a clone of this last element so I can add it to the loft list of sections and rotate it 180 degrees, and hopefully this will make one solid. I've got my doubts. I think we're going to have a self-intersection issue, but we'll try it and see what happens. So right here it's going to be 10 degrees. So we'll use the placement task for this. And what we need to do first is tell it to use this edge as a rotation axis. The way we do that is to select 2 points on that edge. Click the selected points button, and you see this has created a custom axis. So if we wanted to, which we don't, we could move along this axis using the apply axial button, or shift apply axial to move in the opposite direction. And due to the limitations of floating point numbers, it's hard to get back exactly where you were. You see, I'm nanometers away. The NM, this is 0.3 nanometers, which is really tiny. So I'm going to reset. So we're back at 0. And let's use this selected points again to configure the center box. So the way we rotate in FreeCAD is you have a rotation angle, or a rotation axis, which is this vector here, and you have a center location. Those are the two elements of this rotation mechanism. This number here, these three, this vector, it's a user-defined vector that was created with the selected points button. This is a normalized vector, and what that means is this point is 1 unit distance from the origin. Unit in this case being 1 millimeter. So imagine having a 1 millimeter sphere with a radius of 1 millimeter at the origin, centered on the origin. This point is on that surface of that sphere somewhere. So that's a normalized vector. The direction from the origin to this point is your axis angle. The actual axis of rotation is another line that's parallel to this line. Okay, it's parallel to the line from the origin at 0, 0, 0 to this point. It's parallel to that line, and it contains this point, which is the center of the rotation. When we click these 2 points here, when we select these 2 points and click selected points, it creates this custom user-defined axis, and the point that enters here is the middle of these 2 points. The midpoint between these 2 points ends up here. So that's a mechanism behind doing these rotations. So array 1 will be 10 degrees. Array 2 will be 20. So it'll be easy to keep track of how many to do each one. So this one's array 2, it'll be 20. And it's going to get kind of monotonous here. Select the 2 endpoints, click selected points, and then we'll go 20 degrees. Select the item to be rotated. Click on the placement property. Look for these 3 dots here. This brings up the placement task. Then we select our 2 points. Click selected points. And this one is going to be 30 degrees. Let's see if we can get a view here. So each one is incrementally 10 more degrees. And we go to number 4 here. This is 40 degrees. Now you might be thinking, why can't we just select that edge instead of having to select both points? The reason for that is this placement task is part of FreeCAD main. It's part of FreeCAD core. These edges points, faces, these are all defined in the part module. And FreeCAD is designed as a modular application, so you can't have the core depending upon objects defined in one of these modules. It's possible to compile FreeCAD without part and part design and draft. And in order to maintain that capability, the placement task cannot know about these objects that have been defined in part module. Now it knows about points, so that's why we use points here. So I guess if you were going to, as a developer, if you were going to create your own interface with OpenCascade, which is the CAD library used internally by FreeCAD, or perhaps another a different module, then you could do that beginning with FreeCAD Core and develop your own interface. Or perhaps there are other uses for this without those modules. I don't know what they would be, but just to maintain that modularity and flexibility, we can't be depending on objects defined in any of these modules, not in the FreeCAD Core. Part design, draft, sketcher, all of these things use these part objects that are defined in part. But that's okay, because they're not in the core. Without part workbench, very few of these other workbenches would have any functionality at all, because they're making use of these part lines, part faces. Kind of behind the scenes. So we're at 90 degrees, this will be 100. I'm anticipating that we're going to have some problems making this, because it's a kind of an impossible object when you think about it. Yeah, you can make one out of paper and tape, but you're not actually seaming the same edge together. You're taping them together, overlapping and taping. And this is going to be what, 110? Yeah. So I have a feeling we're going to have some self-intersection errors. But we'll see. I have some ideas for trying to work around that. I might have to cheat a little bit, actually. This will be 120. This will be 130. 40. Get near the end now. This will be 160. This could perhaps be done with a script, but I'm not really sure how to generate these axes in a script like that. It could be done. There's no doubt I could figure it out given enough time, but quicker just to jump in and get it done. This will be 160. And I think it's also good to show how to use these rotation capabilities of this placement task dialog, which really, I think they're really cool. And this will be 170. Okay, so we're back to the starting point. Now, this one, I'm going to make a clone of this. Go back to draft. I'm going to clone this first sketch, and I'm going to rotate this clone 180 degrees. It's located in the same location as that first unrotated sketch. And this is going to be added to the list of sections in the Loft tool, in the Loft operation. Alright, let's go back to part now and see if we can do this loft. So we start with number 0 actually. We have to put these in order. I'm just double clicking. Choose to create a solid. And OK. Alright, so why is it black? That's one question. And why do we have this cross? Why did it cross itself? Okay, to answer the first question, yours might not be black because I have in my settings in the view menu here, I have lighting set to one side. And what this does is it shows you when you have a face inside out. And these black faces are inside out. So what we're actually seeing is the inside of this other face on the back side of here, or the inside of this face as it comes around through. It's black on the bottom. Let me create a plane and show you. So here with the plane we have a simple face, and one side is black, that's the bottom or inside, and the other side is silver. So if we extrude that plane, it comes up from the top side. And we have a solid now. And there's a tool here in part reverse shapes. So I've reversed that extrude object, and now all the sides facing out are all black because of the inside. It's inside out. So let me delete those. So this tells me when I have a problem that my faces are inside out. Question is how to fix this. Now this is going to definitely be a self-intersection. Let me save this file before I run check geometry. I'll call this 037 mobius strip. Sometimes check geometry crashes. If it crashes, no big deal, but I don't want to lose what I've done to this point. Yeah, you see a lot of self-intersections here. And when you click on the object in the list here, it shows the bounding box. And sometimes you can see, based on that bounding box, if it doesn't encircle the entire object, you can see where your issues are at. So we're kind of asking FreeCAD to do the impossible here. Now what I'm going to do is try to cheat a little bit by moving this away from the original. Moving this clone back away from the original. Just a smidgen. I'm hiding that loft. I'm going to go ahead and delete it because I can easily redo that. So here's our clone. Alright, let's open the placement task. And because this has been moved, it's not at 0, so I'm going to click apply incremental changes. It was rotated 180, wasn't it? So I'm going to apply incremental. That's going to clear all this out, and that's going to let me move it relative to where it's at right now. And I'm going to select these 2 points to create that axis. But I'm not rotating, I'm moving along this axis of rotation. And I want to go a very small amount the other way. Alright. But I only want to go 1 nanometer, not a full millimeter. So we zoom in. You see that I've moved it by 1 nanometer. It keeps flipping sides on me. Did I go in the right direction is what I'm asking myself now. And change this to M just to make sure. No, I went the wrong way. That needs to be positive, but only 1 nanometer. Now Let's try that loft again. That was my first trick. Hopefully that'll solve it. If not, try something else. We're still getting this problem here. So where is this happening at? It's between 80 degrees and 90 degrees. So I'm going to try to create this in multiple sections instead of one complete loft. Do it multiple lofts. So we had our mistake between 8 and 9, so I'm going to stop at 8 with this first one. And let's see if that works. And then we'll make a new loft beginning with 8. Oops. Don't want those two in it. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let's see if we can make the entire rest of it. Alright. Well, that fixed this problem. Kick the can down the road anyway, so that's looking good. Now we can actually go into the loft properties here and bring up the list of the sections. So I'm going to remove that last one and the 17th one, and let's refresh that. Okay, so we're looking good here. Now let's see if we can loft from 16 through 18. I hope that gives us enough bend. Let's see what's going to happen. Oh yeah. Now, this is actually 3 separate objects. And we got that 1 nanometer of clearance. How long is 1 nanometer? Hang on a second, let me research that. So I entered into Google width of hydrogen atom in nanometers, and it's about 0.1 nanometers. Because the hydrogen atom is the smallest of the atoms. So we're on the atomic scale here with nanometers. And I could go probably 0.1 nanometers. And it will be 1 atom difference. Let's see if we can, let me save this. Might even be able to put that clone, back at 0 where it was. Let's see. Now I want to try to fuse these together. And then let's hide all these sections and set refine to true. I need to hide that polygon. So we have a couple seams there that I'm not real thrilled with. Let's check the geometry. Alright. Now we've got 14 faces. Where are the faces coming from? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and where these two final seams are not meeting exactly is where the other two faces are, I'm thinking. So I had to kind of cheat a little bit and make this in multiple pieces. Now we can display in shaded mode and get rid of all but this last. If we zoom in far enough, if it'll let us. Tell you what, I'm going to switch to zoom back out. Well, I zoomed in a long ways. Switch to wireframe mode. Zoom in and see if we can see a separation. I'm not seeing any. Yeah, there we are. Yeah. No. Of course, when you zoom in so far, it could be you have some crazy funky things happen with your rendering. You really was zoomed in there. I would like to put this back where it was and see what happens if I don't rotate it at all, just as an experiment. If I don't rotate it at all, it's gonna definitely have some self-intersections, I think. Let's mark to recompute. Catch its conflicting constraints. Number 11. what that's conflicting with. Let me clear this. Those symmetry constraints are difficult for the solver to deal with. Now we have 12 faces. You remember we had 14. So I think we've conned FreeCAD into making one of these objects. Yeah, look, that seam line is gone. Well, that's with the shaded view mode. That looks nice though. So we made our object. I have my doubts, honestly, that it could be done. If we switch this to, we're in one side mode, so we don't have any flipped faces. Let me go to mesh design and turn this into a mesh. Well, this is a new mesh algorithm that's been added recently. I'm just going to use the standard defaults and hide diffusion. So here's the STL object that we saw in Wikipedia. And let's view this in wireframe. See, here we are. I really don't like the way that looks too much. Go back to as is. There's a tool here in the mesh design workbench that you can use to diagnose issues. So here's the evaluate and repair mesh dialog. You have all the different tests that you can run. At the bottom here, all the above tests together. We click analyze. And we got no issues, so that's great news. So we could export this now as a mesh object. Export mesh, and we'd have a good STL for 3D printing. This tool here is great for analyzing problems. It can offer to repair them, but I don't think I've ever successfully repaired anything ever with this tool. But it's great for analyzing problems. So you can have duplicated points, you can have non-manifolds, degenerated faces, self-intersections, folds on surface, all kinds of issues. Some of them might not necessarily mean that you're not going to be able to get a print. But if you're having trouble printing, if your slicer is going crazy, come back and check your mesh, and likely there's some sort of a problem with it. I want to try this new mesh creation, Gmesh. I'm just going to accept these, build to start. Well, maybe there's still a few bugs to work out, or I'm not doing something right. I have no idea what these are. Let's try parallelograms. Build to start. Well, let's try NetGen. Very fine. Hide the original. Now let's look at this in wireframe. Yeah, I like the looks of this way better. It looks more uniform than the standard meshing algorithm. Yeah, I really like this a lot better. Just looking at it, there's a little bit of an irregularity to me there. But you kind of want to see uniformity in the triangles that it creates. Let me say a lot more uniformity with that NetGen. Now it's slower. If a more complicated model, that NetGen can take longer to do. That standard algorithm is super fast. So keep that in mind too. Alright, well, that's going to do it for today. We made ourselves a mobius strip. I had my doubts, honestly, that it was going to work. I figured you would have self-intersections, and we were able to get it done using multiple loft operations. Trying to do them all at once, just for some reason those wires got crossed, and it was right at that 90-degree angle of rotation, between 80 and 90. So maybe there's only so much twisting you can do in one loft, where you have to do it in multiple lofts and then just fuse them together. So thank you for watching, and have a great day.